Good evening, everyone. We are Team TechScrum, and I am Grace. I'm delighted to start our presentation. Our presentation is mainly about DevOps work. In our presentation, we will go through something about TechScrum, our project architecture, CI/CD processes, front-end and back-end structures, failover mechanism, monitoring tools, load testing results, security, and some thought about future work. We will address any questions during the Q&A session. TechScrum is a dynamic agile-style project management app. We have prepared a concise video which will give you a quick overview about how TechScrum can work for you. Let's start. This is a front page. It shows the features. TechScrum provides different solutions tailored for requirement of small to medium-sized project. It also offers different pricing options. Let's have a close look. You can create project here, add costs of your tasks. You track costs and sprints. By all this, you manage your project. All your team members collaborate dynamically with each other. All this, with the help of TechScrum, you ensure your project remain on schedule. You see this? Okay, because we don't have a dev team, so that's all about dev. We now go into the DevOps work. This is our project architecture. It may confuse you, but my team member will get you through. We encompass front-end, back-end, monitoring, load testing, security, and some other features. All of this lay solid foundation for the smooth running of our application. We use Jenkins pipelines for our CI/CD tool. We sprung two VM instances on Google Cloud Platform to serve as our Jenkins server. We enhance their accessibility by associating domain names and securing them with HTTPS certificates, which guarantee the secure transmission of sensitive data. Next, I will give floor to Linda, who will tell you more.
Thanks, Grace. Just as see the picture, we have set up a serious pipeline for UAT and the production environment. First, we have the pipeline for Terraform and Ansible. These pipelines are designed to automatically generate AWS resources for the front-end, back-end ELK, monitoring, and security. The second part includes CI/CD pipelines. These pipelines will be automatically triggered receiving a code pull request and handle the process of building, testing, and deploying. We also set up notification for each pipeline. Next page, please. As a part of the CI/CD pipeline, we have included a couple of important features, such as DAST, Dynamic Application Security Testing, SAST, Static Application Security Testing, and the Cypress end-to-end testing. Next page, please. Next is our AWS front-end structure. As you can see, all the resources are set up using Terraform. The front-end code is deployed to the S3 bucket and exposed via CloudFront. We set up the origin group within CloudFront, which include a main S3 bucket along with the backup bucket located in a different region. In this case, if the main bucket failed, the CloudFront will automatically switch to backup bucket. We also create a Lambda function to backup the S3 bucket. This function is triggered through Event Bridge and API Gateway, which means the function can be triggered in the scheduled time. Additionally, user are able to manually trigger this process through the API gateway. We also set up 4 types of alarms to monitor the health status and the data transfer of the application. The teams can receive notification from the email and the Slack if the alarm triggered. We also create a Lambda function to integrate Slack with AWS SNS. As soon as an SNS is triggered, this Lambda function will send the related alarm detail to Slack. Then I will hand over to Stone to introduce the backend.
Hi, I'm Stone. This is our backend part. The backend consists of UAT and prod environments. The UAT includes its own VPC and an ECS Fargate set up without scaling deployed within the public subnet. In contrast, the prod has a separate VPC, and the ECS Fargate runs in the private subnets in 2 availability zones, interfacing with an ALB that connects to Route 53. Both ECS retrieve their environment variables from the parameter store. The UAT and prod VPCs are interconnected via VPC peering. Monitor part will be shown later. Next page, please. So this is our firewall part. Our firewall include an AWS multi-region WAN and a GCP multi-cloud WAN. Linda introduced the front-end multi-region firewall before, so I will just introduce the backend part. When all 3 alarms from the backend trigger, an SNS notification activates a Lambda function. This Lambda function, in turn, triggers a Jenkins pipeline designed to execute Terraform code to deploy the backend firewall in another AWS region. Within the automated setup, an isolated VPC hosts an EKS cluster on Fargate, where applications are deployed by hand. Inside this cluster, the metric server's observations drive the horizontal pod autoscaler to adapt pod outscale. A pod disruption budget guarantees system stability, while an IAM/OIDC provider ensures secure interactions with AWS services. Traffic goes through the AWS load balancer controller and the secured ingress. Next part, Chen will introduce the monitor.
Good evening, everyone. My name is Chen, and I'm responsible for monitoring and load testing in our project. The current diagram displays all the services we deploy for the monitoring aspect of the project, including both front-end and back-end components. In the following 2 diagrams, you will observe monitoring processes in detail for the front-end and back-end. Next page, please. We have selected a combination of OpenSearch, CloudWatch, and the OpenSearch dashboard for our system due to several reasons. Firstly, OpenSearch and OpenSearch dashboard are now efficiently managed by AWS, providing a reliable solution for our needs. Secondly, AWS offers free tiers usage for these services. Furthermore, we already have CloudWatch logs groups and log streams set up in our backend structures, which can easily integrate with the selective services. In terms of data flow, new logs event from CloudWatch trigger a Lambda function, which calls an OpenSearch API. The OpenSearch API is then used to create a log event as the new data in the index. Next page, please. We deploy a self-hosted monitoring setup using the CloudWatch exporter called YACE. It stands for yet another CloudWatch exporter. YACE enables us to integrate AWS CloudWatch metrics into our Prometheus services. For this setup, we use a Terraform script to deploy EC2 instance, followed by the Ansible to configure the EC2 instance. We have automated this entire process through Jenkins, enable us to deploy our monitoring setup consistently and automatically. In addition to our monitoring strategies, we also have set up the alerting system to handle potential issues. We have configured Grafana alerts that trigger when specific thresholds exist. Upon triggering of any of these alerts, Grafana sends a message to Opsgenie, which ensures that our DevOps team receives notifications, allowing us to respond quickly and address issues. Next page, please. After discussing of monitoring approach, let's dive into load testing. Load testing is a process of putting user requests and then checking the response of your application under test. It performs to check the system behavior under defined load and the peak load conditions. In our project, we have chosen Loadcaster as our primary tool for load testing. Next page, please. We have designed several test scenarios to assess our system's behavior under different load conditions and user interactions. For example, we simulate peak traffic by generating 30 concurrent users hitting our homepages, emulating the increased demand during high traffic periods. We also simulate off-peak traffic around 5 users to analyze our system's performance during low demand. Next page, please. We use a payload post method to trigger HTTP 400 serial errors. This helps us to verify our system response to invite requests and assess how these errors are displayed on our Grafana dashboards. And also we use a get method to trigger HTTP 500 serial errors. This allows us to test our system resilience when facing internal issues and evaluate how these errors are reflected on our Grafana dashboards. Next, Jack will introduce the content of security and GCP for everyone.
Hi everyone, my name is Jack. Let me introduce our security part. We use AWS Cloud Trust for run event features of AWS account activities, including Action Utility Hub to centralize views of security alarm and security portraits across AWS account. We also use AWS Single Sign-On, which is a user authentication process that allows a user to access multiple applications with one set of credentials. And then let me introduce our GCP part. We also deploy our application in multi-cloud to increase the availability. So we deploy the backend into the GCP Kubernetes cluster GKE. In GKE, we deploy worker node in Node group in private subnet, prevent device access through the internet to enhance securities. And we have another pipeline to deploy our backend to GCP. In Jenkins, we add credentials, Google Service account on the private key using the JSON file which we create from the GCP console. And we use Kubernetes Engines Builder to deploy in the Jenkins pipeline. And we use seek command to replace the image in Kubernetes deployment YAML file. In the Kubernetes world, we use cluster service to connect the service to each other, and we expose our backend service in public subnets using Kubernetes load balancer service. And we also put our service deployment behind an ingress so that our staff can talk to the application with different paths. That's all for our introduction. Thanks.
To further advance our DevOps effort, we have identified several future work highlights, which include incident response plans, disaster recovery plans, try to integrate more advanced tools, and analyze, monitor, and load test outcomes to replan. This is the end of our presentation. Please feel free to ask questions.